Hi there, Ms. Lambs here. In this video, we will talk about the part 2 of analysis in the biology IA. So this video is mainly about the graph and statistic tests. So from last video, we were talking about analysis takes up about 6 points out of 24 in the biology IA. And last videos, we've mentioned about qualitative data, how do we set up the raw data table, and then a reminder as to what you need to write for the formula and sample calculations, and again reminder things about the process data table. So in this video, we're going to focus on the graph and the statistic test. Now you will notice that for the statistic test I put a bracket if applicable. Now this one we're going to talk about the two-tailed t-test, and it's only applicable for those of you who are doing a discontinuous IV. Okay, so if your IV is discontinuous, then you need to conduct a two-tailed t-test. Then you need to refer to the statistics test in this video. So let's get started. So again, in the analysis part, okay, it's important to present your data in a useful manner. Okay, so a few things to remind you. So in your graph, okay, you should include the following. Such as the title. Now, one of the problem about the title is that a lot of students, the title is very vague. So when you write your title, you should include the IVN and DV in your title. And one more extra part is to mention about what is the error bar made of. In the previous video, we've mentioned that there are two types of error bar. One is made of SD error bar, okay? Another one is range error bar. And we use SD error bar when we have 5 repeats per increment, but we'll use range if we have only about 3 repeats per increment. So this is from the examiner report. And then second thing is about the axis. Okay, so you make sure that your label makes sense, it's detailed enough, and then you also include the unit, okay, in your axis. Okay. And just one more thing, this another common error amongst the students is that they forgot to check whether they have the same decimal place in the axis. Okay, so for example, some of the common ones is let's say the origin is from 0. Okay, so that's 0, and then the next one they say is 1.0, and then next one is 2.0. Now that's a problem because at the origin is not 0.0. So all the data in the axis should have the same decimal place. So how can we solve this problem? You can refer to the Excel the video in the previous video, but here you just check that you click onto the box in Excel, and then just make sure that you convert the data from general to numbers. And once you change the property of that box, okay, then you can adjust the number of decimal place in your data. Okay, so that's one thing you can look into. Okay, always double check. And then next one is plot. Okay, so your plot must show the clear cross. Okay, so this is related to the chart type. Okay, so when you select the type of chart you use to plot your graph, then make sure you select the style that contains a very clear plot into it. Okay, so don't just have the lines only, and that's not acceptable. Okay, so and then next one is it depends. Next one is about the trend line equations. Okay, some experiments don't have trend line. So for example, if your IV is discontinuous, then of course you will not have trend line, and then of those you won't have your trend line equations. Okay, but supposingly there's a trend in your experiment, then I will expect you to include the dotted trend line and also the equation for that. And just another one, final one is make sure your data axis start from 0, 0. This is also related to this. Is related to the chart type that you selected. So when you select the style of your chart, okay, of your graph, make sure you double check whether your data comes from 0, 0. So what happens is that sometimes if they select the wrong chart type, the x-axis, no, actually the y-axis, it will be on -1 on x-axis. So again, so always double check if it starts from the origin 0, 0 of your axis. Okay, so next one. All right, relate to some of the data analysis now. Now, in previous video, when we're on also in IB inductions, we've talked about the correl functions. Okay, so correl function is basically to talk about the correlation between x and y. Okay, between your IV and your DV. And the correl function we quoted as R value. Okay, and basically you enter this function in Excel, and then they will give you a number. And the number, if it's closer to +1, then it will be stronger the positive correlation between so and so, IV and DV, okay? And then if the value is closer to -1, then the stronger the negative correlation between IV and DV, okay? So that's the idea. Now, if you read further in the past examiner report or maybe some of the TSM material, that teacher support material, you will notice sometimes they mention about the R square value. So what's the difference between R value and R square value? R value is talking about the correlation between X and Y, okay? But R square value is talking about how closely each plot is to the trend line. So how close the points, okay, towards the trend line. And if you notice, if it's R square value, that means it will cancel out the negative side of it. So that means if you have negative times negative, then you'll get positive value, right? So it doesn't show very clearly as to the trend. So the key idea is just to make sure you refer them correctly. So R value is related to correlation. R square value is related to how close each plot towards the trend line, okay? But generally speaking, for IA, we prefer a student to mention the R value rather than R square value because it's a lot of students muddle up the idea between the two. All right, so next one. So let's give you an example of the graph, okay? As we in the previous video, we mentioned that generally speaking in IA, we prefer just one graph is needed. Okay, so let's take a look what's wrong with this graph, okay? This graph is extracted from some of the students' homework. So let's take a close look. So of course, title is missing, axis label, okay, is missing, unit is missing, okay. You will also notice this, the shift that I was talking about, the 0, 0 origin. So you can see that actually the y-axis is not on the x-axis 0. Okay, it's not start from the origin. So this has something to do with the chart type that the students select. So make sure you select the correct one. Okay, and then but there's some good parts. So let's say if you have a continuous data, then yes, you should use a solid line for dot to dot and so on. But this graph is very unclear as to what they are trying to measure. And also, this is not a recommend graph as well. You can see that, as you can see, there's actually 3 types of sugar here. Then since we're not sure what the experiment is about, it seems like perhaps they should use a bar chart, okay? Bar chart. Perhaps, okay, again, we need to see the nature of the experiment to decide the suitable chart, but it's not helpful that they don't have the labels as to what is going on, okay? Yes, so let's look at what we need for a process data graph. So of course, we will need our title, including the IV and DV, and for example, mentioning, okay, using a bracket, mentioning what type of error bar we're using. In this case, we'll be using a plus or minus 1 SD as the error bar. You to mention that after the title. And the axis label, axis unit, and make sure they have the same decimal place. And the next one, if your data is continuous data, so for example, if your IV is continuous, then again, you need your error bar, okay? And then you need to have a solid line, dot to dot, okay, dot to dot. And then in theory, you should have a dotted trend line, trend line equation and R values, okay? You can see in the next few slides what does a good graph looks like. And for example, if your IV is discontinuous, then you should use a bar chart. And even in a bar chart, you still need the error bar. But you don't need the trend line because there's no trend there. And then next part, you can pause the video and read this one about the teacher support material about the graph. But if you run out of time to read it, it's just very clearly mentioned, just a few things to mention, is that first of all, you should have the join the data point, so that means it's dot to dot, okay, and then anything else, line of best fit is preferred, okay, line of best fit to show the differences between dot to dot and line of best fit, that means the trend line. The trend line is expressed in dotted format, okay. Yes. Okay. And then type of graph, we just mentioned about it because it's so unclear what this student is doing for the experiment. So you need to look at the nature of your experiment and decide which type of graph is suitable. Is it suitable for a line graph? Okay. Or is it suitable for a bar chart? Okay. So be sensible. All right. So what is a good graph? Okay. So these are some of the examples. So this one you can see here is for example, this is the IV, okay, concentration of zinc chloride. With the potato juice. Okay, so we're looking at the inhibition effect of zinc chloride on the catalase activity in the potato juice. And then this is average rate for the paper disc to rise up. Okay, so related to the in H2O2. So that actually it looks like a curve. Okay, so yes, so you have dot to dot. Okay, it starts from the origin 0, 0. Okay, you got the title that is plus or minus 1 SDS error bar. Okay, so you got the dotted trend line. Now, in hindsight, perhaps this one is not very suitable because it looks like it's a curve. So maybe when they select the trend line, they should select a curved trend line. Nevertheless, it's good. And then try to attempt to mention about the R value. What is it? It's a negative trend. We can see that it's a negative trend. And yeah, that's one. Okay, and then this one is a discontinuous. So for example, they're looking at the type of antimicrobial agents on distilled water, honey, and ginger. Okay, and then they're looking at the number of bacterial colonies. Again, you can see that there's no trend line because this is discontinuous, it's not related. And you can see that there's a SD error bar. Okay, so the student have clearly mentioned that, okay, the error bar is made up of the standard deviation. Okay, so these are good examples. So the next part is when your IV is discontinuous. Okay, if your IV is continuous, you can stop this video, okay, at this stage. But if your IV is discontinuous, I'm afraid you need to continue and listen a bit more. So next part is about t-test. We've previously mentioned about the t-test in the lab related videos, okay, playlist. We prefer students to do the two-tailed t-test, okay, and we've explained why as well. You can refer to that as well. Because your IV is discontinuous, so you'll be using a bar chart, and IB recommend at least 10 repeats for discontinuous independent variables. The reason why we need at least 10 is because you need 10 data to generate enough data to run this t-test. But again, IB prefers students to do 15 times, okay, 15 repeats. Of course, if you have more time and resources, please do that, okay. It also helps with the reliability. The more repeat you have, the higher the reliability. Two-tailed t-test, we'll talk about that already. And report the two-tailed t-test in a table format. Again, in the previous video about t-test, we've already mentioned how you can report the t-test. So you can refer to that again. So just a very quick one is the items that you're comparing. For a two-tailed t-test, you can only compare 2 items at a time. And then you enter the formulas and generate the p-values and then compare with 0.05. If it's bigger, accept the null hypothesis and then you state your conclusion statement. And then if it's smaller than 0.05, you reject null hypothesis and then state your conclusion statement. Okay, and you notice this is a blank because actually it's just an idea. You have 3 items, so therefore you should have 3 comparisons. Okay, so yes, so that was quite straightforward. Okay, so how can we present the t-test, okay, in our lab report? So regarding the t-test, a few things you need to mention. First of all, you need to mention why you need to do the t-test. And then what does the t-test do for you? Okay, so and then state your null hypothesis. Now, null hypothesis belong to the t-test. So it's actually a statistic test part. It belongs to a statistic test. So a lot of students, they muddle up the idea of null hypothesis and the experiment hypothesis, which is completely different things. Okay, so don't muddle up the 2 types of hypothesis. This null hypothesis is restricted for t-test only. So when you do t-test, then you need a null hypothesis. But if you don't do a t-test, then you won't have a null hypothesis. And then you report your t-test in a table format. Okay. And then just a reminder, so this is related to the next sections regarding to the evaluation and conclusion parts. Okay, you need to refer the t-test results. Same idea, you need to refer to the trends that you discover in the graph and so on. Okay, later on in the conclusion part. So you also need to mention, refer to your t-test. Now, this is an example from previous years. So you notice why Miss Sam says, oh, censor here and YouTube itself, because I don't want students to just copy it directly from this video. I want you to use your own wording. Otherwise, you will risk of plagiarism. So here you can see that, okay, what student did is that, okay, so they talk about a section about t-test, and then they were saying that, oh, why they are doing a t-test. Okay, so explain why they do it, what does a t-test do? And then they set up the null hypothesis here. So what is the null hypothesis? And then afterwards, they report the result of the t-test. Okay, so using a table. So it's very straightforward, okay? It's not as difficult as people think, okay? So good that they've explained why you use t-test, okay, and so on. Okay, and the next one. So this is a file checklist. This is from the Green IA guidance booklet. Okay, so as to what you need to watch out for the raw data, process data, and then how you present your graph and so on. So you can pause the video and double check on this one. And then final checklist. Okay, so in this video and from the previous part 1 videos, so in analysis, you should have the following. Qualitative data, raw quantitative data, formula, sample calculation, process qualitative data. It depends on your experiment. Some experiment may not have process quantitative data. Okay, so watch out for that one. Graph. Okay, one graph is enough. Okay, but you need to watch out for the graph element that we've mentioned in this video. And then if your IV is discontinuous, then you need to conduct t-test. Okay, what things about the t-test? And the thing to look out for, key things to look out for in this criteria analysis is that you make sure you standardize your material. So like, for example, the decimal place, for example, how you plot a graph, how you conduct a table and things like that. So I would strongly recommend you to refer to the data presentation guidance, okay, on the TSM, teacher support material. So that's about it for the analysis. I hope this video helps you and guides you along your lab report writing. So good luck and add oil. Thank you and bye for now.